Now it is my pleasure to invite Professor Lenka Zdeborová to the stage. Lenka is the head of the Statistical Physics of Computation Lab here at EPFL, who is a famed researcher in the area of statistical physics and how we can apply methods from that research towards problems in machine learning and compression. She has received numerous awards, including the Irene Joliot-Curie Prize, and she has given the famed Gibbs Lecture as well. So please help me in inviting Lenka to the stage, who's going to speak to us for 10 minutes on AI for science.
Thank you, Antoine, and thank you everybody for being here. So indeed, I want to present to you what's happening in AI for science here at EPFL. So we are all here because something happened with machine learning in the last decade or so. Some say AI is the new electricity, some say AI is the fourth industrial revolution. You have all seen those. Now, all the areas where AI is being applied, science is one of the long-standing endeavors of the humanity. And there have been, in a sense, explosion in the applications of machine learning to sciences that, 5 years ago, even the big journals such as Nature Physics noticed and, for instance, asked me to write this little note, new tool in the box, machine learning being the new tool in the physics box. 2 years after that, me and a colleague, Giuseppe Carleo, we wrote a review of machine learning and the physical sciences where we collected back there 3 years ago or over 400 references. These days, such a comprehensive review wouldn't be possible anymore. Now, back then, I was a researcher in Paris. Giuseppe was in Flatiron in New York. Today, we are both professors with our own labs in EPFL here. So that's the first element telling you that EPFL is the place to be for this topic. And to illustrate that to you, I took 7 little stories from our Mediacom, that's the office that publishes news articles when researchers in EPFL get some great research published. So a few of the recent ones from the last 3 years, one here by the lab of Vincenzo Savona and Giuseppe Carleo's, about simulating quantum systems with neural networks. So when you simulate quantum systems, you need to represent the wave function corresponding to those complicated interacting systems. In physics, we had traditional ways to do it, but they actually took a neural network as a way to represent the wave function and could actually accelerate and improve the simulations by quite a bit. Another story is from the lab of Bruno Correro about predicting a protein's behavior from its appearance. So he uses graph neural nets and geometric deep learning to actually apply on the structure of the protein to predict the behavior, the function of the protein, with the kind of long-term goal to be able to design new proteins with a specific function. The next story is about artificial intelligence explaining hydrogen's behavior in giant planets. That comes from the lab of Michele Ceriotti. So hydrogen in planets such as Jupiter is, you imagine hydrogen in its gas form, but closer to the core of these planets, it actually takes a pretty bizarre metal, very dense form. And understanding the properties of that metallic form of hydrogen requires very advanced numerical simulations, and they are so advanced that we cannot really run them properly in the time we have, but they managed to use machine learning to accelerate the simulation, to actually access pretty cool properties of that metallic form of hydrogen. Next story is about contact tracing. If we were all using these contact tracing apps and had the data coming from them, we could actually use the data to control the epidemics much more efficiently with an algorithm learned from machine learning than what are the uses suggested today. That comes from my lab and that one of Florent Chakala. And before last, one of these stories would be machine learning cracks the oxidation states of crystal structures coming from the lab of Berend Schmidt, where oxidation states is a important property of crystals in chemistry. It's so important that some chemists say, oh, that's actually something that should be included as a little note about it for each element in the periodic table. So it's really important in chemistry, but predicting it and computing it is not evident. And they collected literature and approaches from literature, and with machine learning actually created a system that is able to predict these oxidation states. And another one, artificial intelligence and big data can help preserve wildlife. So that's from the lab of Professor Davis Tua and Alexander Mattis and Mackenzie Mattis, where with using deep learning in a pretty visual way, they argue that in order to preserve wildlife, a lot of these methods are actually really relevant, should be used. And the last one in my list is the one on Epfl and Deepmind using AI to control plasma for nuclear fusion. So you may not know, but just a few hundred meters from here, we actually have a tokamak here at Epfl in the Swiss Plasma Center. And Federico Felici, who is a researcher there, a control of the plasma researcher and his team collaborated with Deepmind to show and to actually implement on the tokamak that is sitting there that machine learning can be used to control the plasma that is being used there. And all that are just, in my point of view, the first rays of dawn, in a sense. The first kind of low-hanging fruits where machine learning could be used to do pretty amazing progress in sciences, and there will be much more. And with that in mind, and showing you that we have a lot of people working on this in Epfl, Epfl is the place to be, and we can lead the acceleration of science with AI, and also attract talents, attract the people who will be the next ones doing that. And with that in mind, we created a AI for Science initiative. What is it doing? The main thing that it is doing is funding postdoctoral fellowships. So if you're a PhD student or you're a young researcher thinking to look for a postdoc, or if you know of some who would be the next ones who will change science using AI, let them know. We want to have them here and work with that diverse team of people that were behind the stories that I presented and more. We have this working group, just around pizza and blackboards, comprising a quite broad range of the labs and professors, and probably more soon, where we aim to identify the questions that reappear in those various applications of machine learning and join forces to solve them. We also have a doctoral lecture on AI for science or scientific machine learning, where if you are from companies and would be looking forward one day to have people in your team with that expertise, well, we are training them. So if you're a student or somebody who knows a student, let them know. And to finish, where do you find us at Applied Machine Learning Days? Today, there is a track AI and Physics. Tomorrow, there is a track Quantum Physics and Machine Learning. And on Wednesday, AI and the Molecular World. And a lot of good fraction of the professors and people that you have seen on the photos on my slides would be either organizing or would be speaking at those tracks. So thank you for your attention.